In this demo, we will showcase our new Agentic Re-Platform Accelerator, or ARPA. To demonstrate its capabilities, we will perform a live automated replatform from SQL Server to MongoDB for a demo application, including a data migration with minimum downtime. It is an AI-driven process, including human in the loop for the key turning point in decision making. The total walk log time for the process is about 2 hours, but the active human involvement needed is barely 15 to 20 minutes. We will use Microsoft AdventureWorks sample application for this exercise. It's a model view controller application that stores data in Microsoft SQL Server. To make things interesting, it accesses database directly from controller, which is an anti-pattern. This application is available on GitHub. Here is the code for this application. You can see that in certain pieces of the controller, it directly accesses the database using Entity Framework. And this is the running application. It allows us to browse certain entities like categories, products, and customers, and view and edit or create new ones. This is our destination MongoDB instance. And this is the main web interface for ARPA. The overall process consists of 3 stages. Preparation, during which we perform the data access layer discovery and refactoring to put it on a golden path. Then we generate new schema design options and perform the final schema design selection. And lastly, we do the execution. We create a plan for the new data access layer, implement it, and prepare for the data migration with Dsync. Each stage has its own instruction, outputs, and review instructions where it's applicable. To start the process, we simply need to click Start. ARPA will delegate the appropriate task and instructions to an agent that runs in the background. We will fast forward a little bit here. When the main process completes, we start the review stage. The process results in a few different artifacts. Specific to discovery, we have data access layer discovery, figuring out how well it's isolated, how well it's covered by tests, and in this application, it's not isolated at all, and there are absolutely no tests. And also the domain object model. We can take a look at these artifacts here. We have some nice diagrams. We have some details. So normally we need to review this, but for the sake of being automated, we can just press next, 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 and just skim through to make sure it all makes sense. These are the interface files. This is the test coverage. Since we didn't have any test coverage, this is the proposed one. And we need this test coverage to make sure that whichever new implementation we make, it conforms to the specification. And this is our domain object model. We can see that in SQL it's pretty complex, but hopefully in MongoDB it will make much more sense. Now let's move on to the next stage, and we will refactor the data access layer. We will not change how it works, we will just reorganize it internally. Once this stage completes, we have a new changed code that we can go ahead and test and execute and make sure that the application still works. The next stage is the assessment, during which the agent will analyze the code base after refactoring and generate information about access patterns, volumetrics or statistics, and a general MongoDB migration assessment. We will need those outputs as inputs to the subsequent stages. This is the migration assessment report, looking pretty good. With information produced by the assessment, we can go ahead and ask the system to generate some schema design options. It will generate a few different ones so that they can all be individually reviewed and the best one can be chosen. So here we generated 3 different options. And now we can go ahead and generate the final schema design. The system will automatically evaluate different options, generating fake data in a temporary MongoDB instance, testing the queries, running explain plans, and doing a very thorough evaluation like a proper consultant would. So here we picked a particular option. As a user, we can review it, we can redo the stage, or we can leave comments with additional instructions. Let's review this document. It looks pretty nice, pretty canonical MongoDB structure with some embeddings. And we also have a script to generate the indexes. Now we can move on to generating the plan for implementing a MongoDB compatible data access layer. It will use a lot of previous outputs as inputs. After that is done, we can review this plan. This is arguably the most important output that as a user or an operator, we want to thoroughly review. We want to understand that it's going to be using a feature flag to switch between MongoDB and SQL, how it will handle auto-generated fields, how it will handle calculations that previously were in SQL queries, and how it will handle other edge cases. It seems overall the agent chose a pretty solid approach, so we are pretty comfortable with it, and we can go ahead and skip straight to the implementation. In case we do have any questions, ARPA preserves the session that we can use to go ahead and ask the agent any questions within the context of that particular stage. For example, we could ask whether underscore IDs are going to be object IDs or something else. With that said, let's continue to the next step. The important piece here is that we are not just asking the agent to generate some new code based on a specification, but it also has to match the original tests for the whole data access layer, so we know that it will be good. Here, after generating the code, we are jumping straight into the code review. And lo and behold, we found some issues and a very nasty bug. It looks like one of the fields, specifically address field, is not even populated in our implementation. It happens with AI. Now all we need to do is to ask the AI agent to fix this. We can use the session reference to reopen the session and ask the agent to implement the fix. After thinking for a little bit, the agent will just implement the proper fix and run the tests again to make sure that everything checks out. At this point, it's a good idea to just try and run the application with MongoDB as the backend database. We'll just implement the feature flag and run it. Here it is running. Since we don't have any data in MongoDB, we see nothing, but we also don't see any errors. To get the data, we need to create a configuration for the Dsync migration tool and then run Dsync. Again, ARPA will make sure that the configuration is created automatically based on the original schema design and the destination MongoDB schema, including all the necessary constraints. This stage creates Dsync configuration files, necessary change tracking script for enabling change tracking in SQL Server, as well as the run command for Dsync. Interestingly enough, we failed the review part here because our SQL Server was not accessible. Once we fix that, we can just safely restart the stage from scratch. ARPA will automatically revert to the previously committed stage and restart the whole stage from scratch using the original inputs. We will also drop the database on the destination just to make sure it's safe. It's actually quite interesting to see how these stages are progressing. We can take a look at these files, the Dsync SQL batch driver configuration file, or the Dsync run command, and we can see as the agent is working and running tests, because during the Dsync configuration review, it is running tests, it's validating the configuration. We can see how it's changing and fixing things. And again, it's doing this completely autonomously. Here we see that the configuration clearly needs improvement, and there we go. We just changed it again. This is our Dsync run command script. It's all written for us. All we'll need to do is to just execute it. Once review is completed, we will have our configuration files for Dsync, as well as details around what was configured and some data that has already been migrated to destination MongoDB instance. So in fact, what we can do is just go ahead and try checking what kind of data is available in MongoDB, see what it looks like, does it look right? In this case, indeed. We can also take a look at customers' documents. Remember, they had this addresses issue. We can perhaps look for customer documents with more than one address. And these are nicely looking arrays, which is exactly what we wanted. And now we can start the application and we can see that it has data. But now this data is in MongoDB. We can create, we can edit, we can do everything that we could do in SQL. But this was a one-time load. With the run Dsync script that the agent prepared for us, we can do a live migration. We already have enabled change tracking in SQL Server, so we can just drop the database in MongoDB and start the sync process. Oops, we got an error. We did not enable change tracking on one of the tables, but it's an error log table and we don't really need it. So we'll just remove it, restart the migration process, and now we can see Dsync is already in the change stream phase after migrating all of the data to MongoDB.